known as its implications for bettering our understanding of wildlife biology. The young scientists behind me here have designed, implemented, and analyzed this study. It's the second iteration of CEI drone studies, and they have been a fantastic group to work with. Please introduce or welcome our CEI turtle drones.
All right, good morning everyone. I'm Riley.
I'm Drew.
I'm Rory.
I'm JJ.
I'm Bronwyn.
I'm Jake. And I'm Blake.
And we are the drones team, and we are looking at the behavioral effects of ecotourism on green sea turtles. Okay, so tourism in the Bahamas is a large stimulus for the economy, and ecotourism alone makes up 20% of the country's GDP and provides over 50,000 jobs.
Ecotourism attracts many tourists to the Bahamas. We are specifically focusing on turtles in this project because they are charismatic megafauna, meaning that many tourists come to interact with them. A simple Google search of where to swim with turtles generates millions of results. An industry has been built around these animals, and it is important that we protect it.
Okay, so two studies we are basing our own study off of are the Griffin and Baven studies. Griffin used in-water observations, or GoPros, to quantify behavioral responses of green sea turtles to find the best guidelines. However, he struggled with his in-water observations because of the water visibility. On the other hand, Baven looked at the parameters for non-invasive drone observations in wildlife biology. This method worked well because he was able to see much more from above.
There is a great data deficiency in what we know about ecotourism's effects on green sea turtles. Green sea turtles are a threatened species, and they have declining numbers, so it is important to see how ecotourism plays into this. Frequent human disturbance can lead to habitat abandonment or behavior change, making turtles easier prey.
Okay, so the purpose of our study is to build off of Griffin's method by utilizing drone technology. We want to be able to quantify behavioral responses of green sea turtles when disturbed by snorkelers in coastal ecosystems in southern Eleuthera.
In our study, we are trying to figure out how size and approach angle affect green sea turtles. We predict that if a turtle is smaller and approached from head-on, it will be disturbed at a farther distance.
There are 6 main steps to our methods. Starting with location, we survey shallow creek systems in the coastline of South Eleuthera because they are both natural habitats for juvenile green sea turtles. Here is a picture of the sites that we have surveyed throughout the semester, starting up north with Half Sound and making our way down to Star Creek, Rollins Creek, and Deep Creek. For a visual reference, this is where we are. So once we arrive at the site and we're ready, we apply a disturbance stimulus, which is a group of snorkelers that mimic ecotourism activities. Here's a picture that a drone captured, and it shows the disturbance stimulus in action, showing that it is approaching the juvenile green sea turtle, which is outlined in yellow. The drone we are using is a DJI Phantom 4 Pro drone, and it flies over the snorkelers at an altitude of 35 meters. Once we are finished with our calculations, we bring it back to the lab and use Adobe Premiere and ImageJ to calculate it. We use Adobe Premiere to split the frames into pieces, and then we use ImageJ to calculate it.
So here are a few key terms that we use in our research, specifically for our calculations in our ImageJ software. The first is the straight carapace length, or the length of the shell. And it's important to note that we do not actually capture the turtles and take morphometrics. We are calculating this using our ImageJ software and drone footage. Then we have our flight initiation distance, which is the distance at which a turtle flees when disturbed by a snorkeler. Then we have the approach angle, which is the angle at which the snorkeler approaches a turtle. And then we have our avoidance distance, which is the distance at which a turtle actively avoids a snorkeler when disturbed without fleeing. So this is a representation of our ImageJ software. In our first frame, we have the straight carapace length, and you can see we use a small line up at the top to measure from the top to the bottom of the carapace. And then we have our approach angle in the middle. It measures from the head of the snorkeler to the head of the turtle, and then from the head of the turtle to the direction that it's facing. And then we have our avoidance distance, which measures from the head of the turtle to the head of the snorkeler. So for our approach angle, we use this model in order to classify the different approaches. 45 degrees to the left and the right of the head is the anterior angle. 45 degrees to the left and the right of the tail is our posterior angle. And 90 degrees to either side of the turtle are our lateral angles. This is a video that we have of a flight initiation distance, and you can see as the turtle is approached by a snorkeler, it flees off to the bottom of the screen. And this is a video we have of our avoidance distance. So as you can see, as the snorkeler approaches the turtle does not flee, but it actively keeps a set distance away from the snorkeler.
Okay, so from the data that we've collected and analyzed, we have been able to draw some preliminary conclusions based on our hypotheses, which is pretty neat. So although this is just a pilot study, we have been able to lay the groundwork for future researchers to continue and build upon. So in this first graph, we are comparing the approach angle versus the average flight initiation distance of the turtles we've analyzed. And you can see that from the posterior angle, we had the highest average flight initiation distance, which could suggest a contradiction to our initial hypothesis. However, when you look at the distribution of the data amongst the three different groupings of approach angles, you see that it's not equally distributed, which means that we can't definitively say whether or not this is a contradiction to our hypothesis. In this graph here, we are comparing the straight carapace length, otherwise the size of the turtles, to the avoidance behaviors. And we do see a positive trend line in this graph here, suggesting that perhaps larger turtles begin avoiding at a further distance than smaller, younger turtles, which would potentially suggest a contradiction to our hypothesis as well. However, since we're still in the process of analyzing, we can't draw definitive conclusions from this graph either, but we're hoping to in the future. Similar to the last graph, this is also comparing size, SLC, to flight initiation distance. And we see another positive trend line, also suggesting that larger turtles will initiate a flight response from a larger distance than smaller, younger turtles. However, we're still processing and we can't draw definitive conclusions from this data, but we're hoping that future researchers can build upon this and help draw conclusions from our hypotheses.
So we want to emphasize that the continuation of this study is vital in order to create more definitive, exact numbers and make best practice guidelines for the ecotourism industries in this area.
Well, analyzing the data, we found that on average, the turtle stays 8.26 meters, initiates a flight response at 8.26 meters from the snorkeler. And while we were in the water snorkeling, we didn't even see close to that distance and visibility because the water visibility was so low. Because of this, we don't recommend ecotourism industries to develop these shallow creek systems in South Eleuthera, because the turtle can sense us, as we saw in the videos, and exhibited some sort of stress, but we, as tourists, could not see the turtle, so we do not recommend moving into these shallow creek systems. We also, these adult turtles are very valuable to the ecotourism industry because they're more mellow and they allow humans to get a lot closer, and so that's like the prime spot for ecotourism. They like to visit those turtles. But if we are constantly disturbing or pestering these juvenile turtles, they might abandon their habitat, and in turn, the ecotourism industry would lose a very valuable asset.
Yeah, and the ecotourism industry is a great industry, and if managed properly and following the best practice guidelines, it creates an industry that's profitable, sustainable, and it instills an appreciation for the natural world and funds for conservation efforts.
Okay. Acknowledgements. We'd love to acknowledge our wonderful research advisor, Bill Bigelow, for everything that he's done advising us through this whole process, guiding us, really being a great support. Kate Kincaid for giving us great feedback on our presentations. Nathan Robinson, Alex Smith, Jack Cuffley, the boathouse staff for helping us make sure the boats get out smoothly and the field days run nice. The interns for helping us analyze the data and also helping us out in the field. The kitchen staff for preparing wonderful lunches. And finally, our amazing family for giving us this opportunity. Thank you all very much. Do you have any questions? Yes.
Do the turtles have any natural predators?
So yes, specifically in these ecosystems, we were looking for lemon sharks in particular, and also historically in the Bahamas there was a turtle fishing industry for consumption, and that was made illegal in 2009. But there is still reason to speculate that it is not entirely gone from the islands. So yes, there are predators, both natural and unnatural, and that might be the reason why they're so skittish, is because over time they've learned to avoid humans.
And also, another negative aspect to if we keep staying around in these shallow creek systems is that they become very accustomed to human interaction, and that means that they don't initiate a flight response, and that makes them more susceptible to human hunting and predation.
Are there current guidelines with ecotourism on approaching turtles and safe distances?
As far as I believe, there aren't specific guidelines for turtles. Only the hunting is illegal now, but there are other conservation efforts like laws against overfishing, but not really any for tourism yet because of the data deficiency of tourism.
Also, the Griffin study, which we mentioned, they came up with the idea that 3 meters is how far we should stay away from these turtles, but they were using GoPros, and it was a lot harder for them to capture all of the data that was going on. So with the drone footage, we could get more bird's eye view and a more accurate measurement because of the image-based software. Yes.
Does any of your research findings impact the potential Disney site? I mean, are they interested in setting up ecotourism in the creeks here?
So definitely that's the goal. So the question was if our research would impact things such as, you guys heard about the Disney cruise ship port that's planning on being built here. And obviously they're not just coming here for the fact that they could build a cruise ship port. There are a lot of things here that are very interesting. As we said, turtles drawing a lot of tourists. So it's definitely something that they're probably looking at because it's something that people come here for. And so that's why we're trying to look at this, and as Blake was saying, we think that these areas, since they're so vital to the development and maturing of these turtles, they should be protected, especially because you can't see them. So there'd be no reason to bring people into these areas because it only causes harm and it doesn't benefit anybody, the turtles, the people working in the ecotourism industry, or the tourists themselves.
Would you guys ever consider using the drones to conduct surveys?
We already do that. So the drone's been used for many things. This one was in particular this study, but in the past they used the drones to fly over the creek systems and do population surveys and stuff like that. And then they'll go back through with people and see if the numbers are similar so that they can see how reliable the drones are. Because if we find that the drones are more reliable or just as reliable as people, then we can just have them have set courses to fly around the creeks. We can map it out and have it so that we can have a very up-to-date, constant number of turtles in these systems.
Is there conservation organizations like land trusts or government regulations like zoning that prohibit development like that, or might steer development in a way that's more balanced with the natural world here?
So here in particular, we were looking especially at these previous studies. As far as like terrestrial animals and stuff, you've probably been to places like national parks and stuff like that where they're very specific, like, oh, stay on the path, don't approach an animal, don't feed the animals, that kind of stuff. They're much more lax with the guidelines as far as marine animals go. And in this area, especially because there aren't such huge industries here, it's pretty much, it's not necessarily free-for-all, but there's not a whole lot of policing that goes on in these areas. So as far as here in particular, no, there's not really guidelines that are put out or followed.